Hello and welcome. This is Dhirendra. Welcome back to our channel. So today we are going to derive Kepler's second law, that is the Kepler's law of areal velocity. In the year 1609, Kepler began to discover these laws. The Kepler's law of areal velocity states that the area swept per unit time, that is dA by dt, is equal to a constant. If there is a geek inside you, and if you want to go for details, then this constant is going to be L upon 2m, where L is the angular momentum. Okay, L is the angular momentum given by m v r, where m is the mass, v is the velocity, and r is the separation from the star. So the angular momentum of this planet that is revolving around the star is given by this formula. We can rewrite this formula in terms of angular velocity as m omega r squared. Now this omega is actually the rate of change of angular displacement. So the first thing that we are going to make is the sector. Okay, suppose this is the star and our planet sweeps from location M to location N, and then it sweeps a tiny angle delta theta. Now, in order to prove this law, what we need is the area of this sector that we are going to approximate as a triangle. Okay, so area of this triangle SMN I will represent by A is equal to half of the base. Now base is the NM, that is the arc length. Now this arc length is suppose small l, okay, times the perpendicular. Now since this triangle is really tiny, we can say the perpendicular distance is just the separation r. All right. Now we also know this tiny angle theta is equal to arc length divided by r. Therefore, we can write L is equal to r delta theta. Okay. So we will plug in these values here to obtain the area A. Actually, this is a tiny area, so we will represent by delta A is equal to half of r delta theta times r. Okay, until here everything is clear. Now we are in business, so we can rewrite this as half of r squared theta. All right. Now, what we are going to do is we are going to write the tiny area of this sector is equal to half. We are going to multiply m on top, and we are going to divide by m r squared theta. Now, if we take the time interval delta t, then we can define the areal velocity for the area swept per unit time as half mr squared delta theta by delta. Now this we can rewrite as mr squared omega, because this is our angular velocity. Okay, here we have defined, divided by 2m. And you can clearly see here we have the expression for angular momentum. Now the angular momentum is a constant because the planet is moving its orbit, and the external torque on this planet is zero because all the forces are internal. And internal forces do not cause any external torque. So that is why the areal velocity we can write as L upon 2m. All right. So thanks a lot for your attention. Have a great day. For more such content, please don't forget to subscribe and like.